All right, we want to solve this inequality and graph it on a number line. What we have is a quadratic inequality. It's x squared minus x minus 6 is less than 0. We want to find out what intervals make this true for x squared minus x minus 6 less than 0. So the first step we want to do is we want to factor this quadratic piece. So if you remember factoring, when you have the leading coefficient of 1, we want to use the chart method, and we say, what are the factors of negative 6 that add to negative 1? Well, those two numbers are negative 3 and positive 2. So I split up the x squared as x and x, and then I have minus 3 and plus 2. And I haven't done anything with it less than 0 yet. I'm going to get to that later. So we're looking for intervals. First thing we need to do is find what we call critical points or critical numbers. This is a very important thing when you move into calculus next year, that you understand critical points or critical numbers. So we want to take these two factors and set them equal to 0. So we have x minus 3 equals 0 and x plus 2 equals 0. It's kind of like the zero product property. And we solve them for x. So we're going to add 3 and subtract 2. So these two things are called the critical numbers or critical points. Now what I'm going to do is I'm going to graph those 2 points on a number line. So if we think about our number line, if here is 0, 1, 2, 3, negative 1, negative 2, negative 3. And we graph those critical points as negative 2 and positive 3. Now we're going to set up intervals. We want to find out what happens to the left of negative 2, what happens between negative 2 and 3, and then what happens to the right of 3. So I'm going to break it up into 3 intervals. So here's my first interval, going from negative infinity to negative 2. Then I have a second interval going from negative 2 to 3. And then I have my last interval from 3 going off to positive infinity. And I want to find out which intervals are true when it is, noticing this, less than 0. So we have to choose test points. So we want to find out when is it less than 0. So I'm going to choose a nice number in each of these intervals. I'm going to choose negative 3. I'm going to choose 0, and then I'm going to choose 4 as test points. So I'll call this TP, kind of funny, TP, test point, test point, test point. And then we'll call it these other points CPs, critical point and critical point. All right, let the fun begin. I have to test this original inequality, this quadratic inequality, with 3 test points. So let's talk about that first inequality first. Actually, let's write down what the quadratic inequality is again. I need to know that. So here's my quadratic inequality. I'm just going to grab it, clone it, and have it down here. All right, this is what I'm going to be working with. So in that purple inequality, my interval is from negative 2 to negative infinity to negative 2. My test point is, I'm just choosing negative 3. So any point within this interval right here. And I'm going to substitute it into this black inequality. So I say negative 3 squared, and I'm replacing it with x. Negative 3, and then minus 6. And I want to see if this is true or false. So I'm going to use my orders of operations and simplify it. So negative 3 times negative 3 is positive 9. And then negative 3 is a positive 3. And then minus 6. Now combine those terms. 9 plus 3 is 12. 12 minus 6 is 6. Now let's read this inequality. Is it true that 6 is less than 0? No, that's false. So the interval in the purple is not true. It does not work. So we can cross this out. Not possible. Now let's go on to this red inequality next, or interval. Going from the negative 2 to 3. And I chose the test point of 0. Remember, it could be any point along this interval. Now I just chose 0 because 0 is a nice number to substitute in. And I want to see if it's true or false. So my interval is from negative 2 to positive 3. My test point is 0. And I'm substituting into that black inequality. So 0 squared minus 0 minus 6 less than 0. So we use our order of operations. 0 times 0 is 0, minus 0 minus 6 less than 0. On the left side, we get negative 6 less than 0. Now read the inequality. Is it true that negative 6 is less than 0? Yes, it's true. Or you can say that 0 is greater than or equal to negative 6. So we say this is true. So this interval is a solution. All the ordered pairs from negative 2, just a little to the right of negative 2, and a little before 3 are possible solutions. Now we have one interval to still continue checking, this black one here, where it starts at the critical point 3, and it goes off to positive infinity. The test point that we chose is 4, when x equals 4. So our interval is from 3, I just take the same colors here, 3 to positive infinity. Our test point is 4, and we're substituting that black inequality. So 4 squared minus 4 minus 6 is less than 0. So we get 16 minus 4 minus 6. 16 minus 10 is 6. Read the inequality. Is it true that 6 is less than 0? No, that's false. So this interval is not true. You cannot have any solutions from 3 to infinity. So we would say the solution then is the interval from negative 2 to 3. Or if you want to write it as inequality, it will look like that.